Yeah, typically little region of subclass. This collection, the class does what it does well, what it's designed to do, maintain a ordered collection of objects from the documentation. The documentation, yeah, actually now says just don't do this. So some handy classes that are included in the foundation, which is foundation for OS 10, for OS X, and for iOS. NS string, you're going to use these all the time, and here are some of the more more useful and more used methods for NS string. So plus sign means for method, class method, yes. So this class method is string with format. You pass it an NS string. You pass it a constant NS string that contains printf formatters, and then a comma-separated list of objects or types or variables or constants that you want to have embedded in your string. This is this is the Objective-C way to do sprintf. But you'll notice it's a class method to create a string and return a string back to you. If you've already got a string and you actually want to change the contents of it to have a format, or you just allocated it yourself and you initialize it, and you want to initialize it with a formatted string, you use the instance method and it with format. It's the same thing as string with format. Same kind of arguments, a printf style argument list, and then the arguments separated by commas. But this is an instance method that doesn't return you back an NS string pointer. This is if you've already got an NS string pointer allocated. Clear? Lowercase string, obviously, a method on NS string alters the NS string and gives you back. Does it give you back a copy of the string?
Yeah, I mean, it doesn't modify the original object.
Right.
It gives you a new string object that's the lowercase version of the same string.
Right. So NS string by itself, just like other collections, NS string is just a collection of characters. It's immutable. So, and all of these instance methods that modify the string don't modify the original string itself. It returns you back a copy of the modified string. So, for instance, this lowercase string, if you call it with an NS, an NS string object that you've already initialized and maybe even formatted, it gives you back a copy of the string with all of the letters in lowercase. Your original string remains unchanged. Does that make sense? So, length is an obvious one. Give me an integer back, length of the string. Int value, float value, double value, and bool value are really handy convenience methods that are a lot like ITOA and ATOF from C that give you back an actual native value from a string. So if you have a string of quote unquote 10, you can get its floating point value 10.0 or the double value or the integer value 10 out of it by using these convenience methods: int value, float value, double value, and bool value. Doesn't change the string, just gives you the value back. Is equal to string, you saw this last time. You pass it in another NS string, and it gives you back a Boolean telling you whether or not the strings are equal to each other. Really straightforward. Substring to index gives you a copy back of your original string of the, substring up to index. So this is going to give you the first n characters up to the index that you passed in. So you have hello, you say substring to index :3, you'll get HEL. Pretty straightforward. And then the flip side of that, substring from index will give you the last index characters of a string. So hello, string from substring from index to is going to give you ELLO. No, LLO. Range of string. This is an interesting one. So, if you have a string, say hello world, and you pass it in a string that you're looking for, a substring that you're looking for, real common in C and C++ and Java, substrings that you're looking for, you pass that in and it comes back with the range of where those characters exist in that string. NS range under the hood is a double.
It's a structure.
That's right. It's a structure that has that contains where the initial string was found and the length of the string. It's not value 1 to value 2. It's where it found it and then the length of the substring. Has prefix. That's also pretty straightforward. You pass in a string and look to find gives you a Boolean back of whether or not this string is sitting at the end of the string that you call this method on. Yes.
Why did the first two return 8 instead of an NS string?
That's a good question.
They could.
They could. I'm not sure why they don't.
All initializers return 8, just always.
So keeping with consistency with the rest of all of the initializers, because your initializers are written so generically, and because you can install initializers dynamically at runtime, you'll see that all of the initializers for whatever class all return an 8. But you're absolutely right that it could return it in a string pointer. Is there a question back here? Yeah.
So why do some of these return pointers like NS pointers, whereas the integers and integers are not?
Okay, so every single Objective-C object is a pointer. Always a pointer. Pointer, 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 pointer. Always. However, the native types that come back when you're just getting a value back, you don't want the address of that value. You want the actual value back. So these NS string pointers are going to give you this lowercase is going to take the original string, allocate some memory that's exactly the same length, lowercase all of the letters, return you back a pointer to that lowercase string in memory. When you call length, you don't want it to allocate space for an integer and then fill it in and then return you back a pointer to that integer. It can just return you back the length of that string within that native type, within that integer type. So unless you see otherwise, all of the native types are just going to be returned back by value as opposed to being returned back by pointer. Yes.
By native type, do you mean that there are structs underlying the type in Objective-C?
That's a really good question. So this should all be abstracted away so that you don't need to worry about it. So by native types, I guess I should
say primitive types.
I should qualify that. When I say native types, I'm usually thinking native to C, as opposed to saying native to Objective-C and native. So let me back up. I'll say primitives for C types, and I'll say, and then I'll stick with native types to be Objective-C or Foundation or Cocoa classes.
I mean, you really shouldn't concern yourself with the fact that objects are pointers, because you'll notice we never dereference an object, so you just kind of always just assume that objects are pointers and just kind of leave it at that. Everything else is not going to be a pointer, unless you need pointers for something that you're doing.
Right, unless you've got a really good reason, and usually that involves like some serious debugging, or if you're doing kernel work or things like that, or driver work, you usually never need to dereference the pointer. You're always passing those pointers around and using those pointers. Is there another question over here? Okay. So NS number is another native type for Objective-C. Two class methods here. Number with an integer takes a primitive type, an integer, C integer type, and returns you back an object, which means that these are perfect for installing in collections, yes. So here's the wrappers. This is what, if you want an NS array or an NS set, or if you got a dictionary with keys that you want to use integer values for your keys, or double precision or floating point primitives for your keys, this is how you wrap them. Number with int, number with double, number with float. There's a whole range of these wrappers that you can look up in the documentation. There are also instance methods as well. So if you've already got an NS number, you can, say you've allocated already, you can do an init with float, pass it a floating point value, and it gives you back a copy of the NS number that you can then use within your collection. And NS numbers, they also respond to the messages like char value, long value, double value, float value, that can give you back out the primitive types that you've wrapped around them with the NS number. The people may think wrapping and unwrapping is, how wasteful, how costly. These are actually under the hood. This is all abstracted away from you, but this is all incredibly fast.
Yeah, unlike Java's capital integer class and capital float class and all of those classes, which are expensive to box and unbox the values, these are not expensive to unbox and unbox.
Right. So does this make sense? Wrappers for primitive numbers. So NSDate is something that you saw last time. NSDate is the underlying architecture you don't need to worry about, but it represents just one single point in time. You can create them with the class method date. You can give a date with a time interval since now, where you give it a number of seconds and it'll return you back a date object that represents a point later in time. A lot of times these are used for timers. Like if you have a 60-second timer, you say, okay, give me a date with the time interval since now as 60 seconds, and it'll give you back a date object that you can then use in your timer for when you want it to fire. And you can compare dates as well. Time intervals are always given in seconds. Underneath the hood, that's a floating point number. It's a double precision number, so you get sub-millisecond precision to 10,000 years. So NS time interval is you shouldn't have to worry about precision with that. People say, oh, why not specify it in milliseconds or microseconds or picoseconds or nanoseconds? You specify everything as a floating point number of seconds, and the precision is really, really good. Distant future and distant past are really interesting ones. These are class methods. Distant future says, I need a date that's way, way, way out that I don't ever want to hit, ever. These can be used for, say you've got a process that you want to run forever, and you don't want to have to create a specific, that it takes a date, but you don't want to have to create a date and then add a bajillion seconds to it to get a new date that you could use. That's what distant future is for. Give me a date object that's way, way, way out that I'm never going to actually run into, and it's basically like a placeholder that says, run this forever. Yeah?
Is distant future always the same?
I have no idea. The only thing you need to worry about is that up at the abstraction layer is that distant future means you're never going to run into it. If your program is running for 10,000 years, you might hit it. You shouldn't have to worry about it. Okay? Same thing with distant past. Distant past means way farther back than computers were ever invented. So this is used for, when was this used? I forget what the example. There's a great example for this. It comes in handy when I don't remember. It's in the documentation. I can't recall off the top of my head. there is a good reason for having distant past, which means